bunch of slides, but mostly code and application running. Of course, the whole session is about how to use Azure SQL and by extension also SQL Server and OpenAI to build an application on your own data that can do interesting stuff with AI. So we dive into that. First of all, we see some high-level concepts just to make sure that we are on the same page, and then we'll just go into the solution and see it live, see it how it's made. Actually, the solution is available on GitHub for you. There are two versions. I'll explain why there are two versions. But you can just go even today on the GitHub repository and just deploy it in your subscription, or even just use it locally, as I will be doing in the demo. I'm Davide Mauri. I'm a PM in the Azure SQL team. I'm focused on developers and developer experience. I am a developer. I love developing, creating stuff, but I also love data. So that's why I'm in the Azure SQL team. You can find myself in many conferences, this one, Ignite, Build, many others. You can also check out my website and especially the blogs where I post what I'm working on or some cool stuff, for example, Vector with Azure SQL. And also I have a Twitter account if you want to follow me. I just usually post only work-related stuff. Make sure to download the application and then do the evaluation of this session. I'm pretty sure you already know that from other speakers, but make sure that you do it. It's very important. And I have another survey to ask you to do, and this is very important. Not that the one before wasn't important, but this is very important for us, for the product team. This is a link that you can go to right now, or even just scan the QR code, where we ask you what you want from Azure SQL. Like, what are your pain points? What are the features that you would like to have? And this is very important because 2 years ago, and actually now more, 3 years ago, we did the same survey. It was more like face-to-face than online, but we asked developers, what do you want? And many developers told us, oh, I want the ability to call a REST endpoint. I want the ability to expose a storage procedure or a view or a table as a GraphQL endpoint. I want the ability to integrate Azure SQL with Azure Function. So anytime something changes in my database, an Azure function is executed. And all these things, or JSON, better JSON support, regular expression. So all these things that we've been told the developers would have loved to have, we are delivering it. Some are already delivered in GA, that you will see also in the demo. Some are incoming, like JSON support and regular expression and even vectors. So it's very important for us that you give us the feedback. It's a very simple survey. Let us know what you want, because that will help us to drive our priorities and make sure that SQL Server and Azure SQL is the product that you love and use, and it helps you to be more efficient and just happier every day. Having said that, I will show this again before the end of my session. What we are going to do today is basically this website, how we can build this website and how you can actually replace this website or at least the data that this website uses with your own data. And what is this website? It's ai.microsofthq.vslive.com. Maybe you already used. I tweeted about this. I posted on LinkedIn. And if you go right now, you will be able to chat with AI about the session that are going on right now. For example, you can ask, actually, let's do it together. You can ask, and I need to do this before, so duplicate, here we go. You can just go here, ai.microsofthq. And let's ask, I don't know, I'm interested in security. What are the sessions I should attend? Okay, attend. Whatever, I don't care about misspelling. The AI will be smart enough to understand it. So what is happening right now, it is running a vector search on Azure SQL data. Again, right now I imported all the session abstract and title and speakers of this conference, but it's running a vector search on that data. And then it's passing the vector search result to an AI model, a ChatGPT model, so that it can understand my natural language query and understand the result coming out from the vector search, and then return the result such in a way that they are adherent to what I have asked them. So in this case, for example, my question is about security. So Bob Ward is doing a session on how to build secure and scalable applications. So pretty much on topic, right? Let's do something fun. I want to learn how to cook pizza. Well, let's see what the AI will come up with this idea, with this question. And of course, the answer is, well, there are no sessions about pizza. You are at an AI conference, so it's nice. It doesn't even ask me why I'm asking this weird stuff, but definitely is able to, in quote, understand not only the data that it has in database, but also the context and the fact that we are in AI conference. And also you can see also the thoughts that brought the AI model to give you that answer, right? So it's very interesting. Now the question for you, I guess, in your mind right now is, okay, this is cool. How can I do exactly the same on my own data? Right? I have maybe feedback from customer. I have contracts that are, with data, maybe PDF extracted and stored in Azure SQL. I have comments. I have anything that can be fed to an AI. And I just want to be able to talk with my data just like I'm doing it right now. So this is exactly what we are going to build today. Now, before going and seeing how this is built, let's just take a look at the architecture. And even before that, let's do a step back. Again, probably many of you are already familiar with this terminology, embeddings and vector, but just in case, I will take 5 minutes to just go over the foundational aspects of what is happening behind the scenes, so we are all on the same page. So the first thing that you have to understand here is the concept of embeddings. Embeddings are nothing more than a fancy word, if you want, for vectors. Vectors are a sequence of numbers that represents usually a point in space. And in this specific case, the vector that I just came up with some random number there, you see on the right, represents that concept I wrote on the left. So I say here that the foundation series by Isaac Asimov, which is one of my favorite series and author, is represented by that vector. Now, how come that topic can be represented by a vector? Because that vector is generated by an AI model, an embedding model, that is able to transform some topic, some information that exists in the real world into numbers. Now, why this is important? Because if you have at some point some number, you can calculate the distance between another number. 3 is closer to 4 than 5. Now, if I can calculate the distance between two numbers and those numbers represent concept, then I can calculate distance between concepts. So if I'm searching something like, give me all the books that are somehow similar to the Foundation series by Isaac Asimov, and I have a list of all the books, maybe with the abstract of the book or the description or the title, well, I can return you all the books that are similar to that topic. Now, the similarity here is a concept that is determined by the AI model you are using. So depending on the AI model you are using, you may have more or less similarity. But for example, in this case, in the AI model that you can use in Azure OpenAI and OpenAI by extension, have been trained all on the word data, so they are kind of able to understand our word and generate a representation of a top of any topic into an embedding, a vector, so an embedding, so that for us it's then possible to use that vector to figure out what other topics are similar to the original topic that we are searching for. For example, before I was looking for sessions that are about security, and I got the correct answer, right? So the first step is to make sure that our text or our content is transformed into an embedding. And to do that, you have to use a specific AI model called an embedding model that is available on OpenAI, for example, in Azure OpenAI. There are also models that you can run on your machine, open source model, but in general, the first step is that you need an embedding model to turn your text or your content, your payload, into a vector. Now, once you have a vector, you want to calculate the distance. Now, to calculate the distance, there are many ways. It could be, the most common is what is called the cosine distance, which calculates the angle between 2 points in space. Now, a vector, if you represent a point on Earth, for example, is a two-dimensional coordinate because it's the latitude and longitude, right? Let's set aside, for example, the elevation, but latitude and longitude. So you can imagine that you can calculate the distance between 2 points on Earth just by calculating the distance between these 2 points in space. You can do the same with with the embeddings. The only problem with embeddings usually is that they have a lot of dimension, not like 2 or 3. They have 100 of dimension, if not 1,000. Actually, the most common AI model produce a vector with 1,500 dimension, right? So the calculation may be a little bit longer, but it's simple. At the end, it's just calculating the cosine, so the angle between vector 1 and vector 2. The closer the two vectors are, the smaller is the angle, at the point that if two vectors are exactly the same, they are representing exactly the same thing, and in the case, the angle will be 0. So if you use the cosine distance, 0 means that two topics, for example, a dog here with his representation in terms of embedding on the left, and a cat here, with the vector representation on the right, we can calculate the cosine distance, and then we will discover that the distance is 0.13. It's very close to 0, which makes sense because the cat and dog are, well, not the same, but are somehow two animals. They have all 4 legs. They are all living with mans. They are all domesticated. So it makes sense to say that they are somehow similar, not exactly the same, but somehow similar. Now, just to prove that this concept works and works well, we can ask ourselves, well, in theory, if I now check against a wolf, so a dog and a wolf, I should have a slightly different answer. Probably my opinion, and here is why I use this example. In my opinion, a dog is more similar to a wolf than a cat to a dog, right? But others may disagree. Like you're saying, no, if you just take a look at the animal that lives with men, definitely a cat is more similar than a dog, right? How the similarity will be calculated is always the same, but the vectors generated by the AI model will be different depending on how the AI model has been trained. So with the model that we are using right now, if I calculate the distance between a dog and a wolf, you will see that the distance is a little bit smaller. So for my AI model, the dog and wolf are closer in similarity than a dog and a cat. If you use another AI model, or even create your own, you can decide if that is true or not, right? But so the important part here is that embeddings are vector. Vector can represent point in space. We can calculate distance between point in space. Since we can calculate distance, we can find how close or distant 2 points are. And if those points are related to some subject or some topic that we convert into vector, now we can find basically if the two topics are somehow similar or not. Basically, we can do something called semantic similarity. So we try to understand if two semantical meanings like a dog and a cat or two topics are actually similar or not. And then we can order them by similarity and take the most similar. Now, this is the first step in order to be able to talk with your data, because what you actually really need to do at some point is also understand the natural language and then tell it to the AI, okay, this question is, can you tell me all the session related to security? And then the AI must understand that question and then return the correct answer. Now, this process of talking with your data is called RAG, Retrieval Augmented Generation, where basically you say, I have my bunch of data, but I want to be able not only to just return you just the row that satisfies your condition, like give me all the sessions that are somehow related to security. What you are asking a RAG system is return me a answer that is in natural language that explains to me or that tells me exactly the answer as a human would have answered to me. So if you tell me, you know, I want to learn about security, what you advise me to go? Well, I can tell you, okay, you know, there is this session and there is the other one. And so I can give you some options. Then I give you some hints on which one may be better for you, depending on what you told me you're interested in. It's exactly what happened before, right? When I was here and then I got my answer. Now, interestingly, here I asked the question, right? And so I was chatting with my system. And I want to show you why it's important to have this two-step process. So the first one is doing vector search. So first of all, we need to figure out all the sessions that are similar to the topic I'm interested in using similar semantic search or vector search. But that is not enough. Because if I only use vector search, just to make sure that the sessions are returned in order by how similar they are to a topic, what can happen is that I take this context, this text, this topic I want to be compared against my session. Now here I'm on the tab search. So here I'm only doing semantic search or vector search. Let's see what happens. So this is going against Azure SQL, is converting the text that I typed here in embeddings, and then doing the calculation of the embeddings related to this text with against all the embeddings I already stored. And you can see it still gives me some answer, which is pointless because there will be no session here that will teach you about cooking pizza. But that's the difference between just pure vector search that will just try to give you the most similar thing, even if there is nothing similar here. But still there is the 2 point, even very distance between each other, still will return some numbers, right? And so you can always return, for example, in this case here, the similarity is 0.25, which is, okay, it's just a number. This is the most similar, but it's not similar at all because in this case, similarity is the opposite of distance. So the most similar would be 1. Similarity equals 0 means completely different. Similarity is just the opposite of distance. 2 vectors and 2 topics are similar if their distance is 0, right? So here I'm just showing the distance because it's more easier for human to understand. But similarity is 0.5 means that they are not similar at all, basically, right? And which is exactly what we expect because there is no pizza session in this conference. But still, the vector search is returning something to us, right? Yeah, we can filter about setting a similarity, higher than a certain threshold. But again, that will be kind of, hacking a little bit the system to find the right threshold to make sure that you don't get the data that you don't want to show because they are not applicable. Or the other option is that we take all this session, we send them to the AI model, another AI model in this case, not the one that generates the embedding, but one that is able to understand our language, so a GPT model, for example. We send all this information, and then we add, as a payload, in addition to all the session here, the question like, dear model, please, among all these sessions I'm sending you, return only those who are able to answer this question. And as you saw, the AI model is able to understand that all those sessions that are still somehow similar, they are not applicable to this context. And so they are filtering out those sessions and say, hey, there is nothing there for you. Of course, if I say I want to how to build secure applications, you will see that now we have a more decent answer. And exactly, so how to build secure and scalable application, again, perfect. So this is what I want to do, and this is why we need this 2-step process. The first step is finding all the similar session, and second, taking all these similar session and shipping it to a more advanced AI model that is able to understand the session, to understand the answer, and then produce the result. Now, the question could be here, well, why we don't just ship all the session? Like the AI model will be able to figure out anyway, even if we give all the 1,000 sessions that we have. Let's pretend we are at build, so we have a lot of sessions. Will it work? Yes, it will work anyway. The only problem is that you are abusing and overusing resources. AI models are expensive to run, expensive for you because you pay by tokens. Tokens are a set of words. So the more data you send to a model, the more you have to pay. So that's why you want to send a model only those sessions in this case that are somehow relevant. There is no point in sending a session that is absolutely not similar to what I'm searching for, right? Because I will just be spending money to get the answer I already know, like this, there is no session about pizza. So you want to do some vector search or similarity search in order to restrict the result set that you are sending to the AI model so that the AI model is more efficient and less expensive for you to run. So that is the 2 steps of a RAG solution. And since you probably heard about this new term called prompt engineering, that is exactly where prompt engineering fits, and you will see it in action. But basically, once you send all the session to this AI model, you have to explain, like to a 5-year-old person, what to do with that session. Like you have a session list. And the AI model will be asking you, what do you want me to do with this list of sessions that you are providing? And you have to explain, dear AI model, you have to behave like an AI assistant that assists people going to VS Live conference to choose the best session for them based on the question that they will ask you. So you really have to talk with the AI model like you're explaining someone that has no clue of what you want to do, how to do that, right? And that is called prompt engineering. And it's very important because the quality of prompt engineering is directly proportional to the quality of the answer you will get. And we'll see that also in a few minutes. Okay, the architecture we are going to build, the high level is this one. So we have the client application on the left. That is just a React application. So it is a full stack architecture. So we have a client application that communicates with the backend only via JSON, and the backend exposes a set of API, REST or GraphQL here. And then basically the backend is then connecting to Azure SQL to store the vector, to do the vector search, or to an Azure function to call the OpenAI model to do, for example, the natural language understanding using the correct model and then getting the answer. Specifically, we are using a little bit, at the end, if you really look at the architecture, it's a little bit more complicated because there is no just one function, there are a couple you will see in the demo. So it's slightly more complicated because physically I had to separate the function in two different calls. But logically, it's like there is like some back end. One is just doing CRUD against database, and the other has a little bit more advanced kind of logic inside to do the prompt engineering. Now, I just also shown the tail architecture because I want you to see that I'm going to use the static web apps here. I'm going to use Azure Function, Azure SQL, and Azure OpenAI, and everything here is serverless. I will also be using Data API Builder. If you went to this morning session by Jerry, he showed GraphQL and Data API Builder support. Basically, Data API Builder allows me to say, hey, this storage procedure that does the search, expose it as a REST endpoint. That's it. So I don't have to build the entire backend to expose a storage procedure just to serve the data that is, being requested via POST or GET. I can also choose to expose the storage procedure at GraphQL, but it's just a free tool, completely open source. It's GA already, so you can also go and download it today, use it on your Azure SQL Server, and you just pick and choose the table or the view or the storage procedure, and it will take care of everything for you in order to expose that object as a REST or GraphQL endpoint. Now, some questions here arise that related to this architecture is, okay, this is nice, but this is all serverless. I don't like serverless. I prefer container. Great question. The same architecture, the same code, of course, deployed in different services can also be executed completely in container. And actually, my goal for the next month will be to take this code and make it run in Aspire. So we have a nice containerized application, microservice solution. But exactly the same code, of course, you will not deploy the code in Azure Function. You will deploy it in a C# service running in a container. Exactly the same process can be completely deployed in containers if you want. Data API Builder is already containerized, so you just have to download the image from MCR. Of course, you can easily create a .NET application in a container. The React application can be containerized. So everything is really easy to containerize here. Okay, so, but for my solution and for the solution that you will be finding already on GitHub, I'm going to use static web apps because it's one of the services I love most in Azure. It makes my life as a full stack developer so easy. For backend, I will be using Data API Builder, Azure Function to handle the natural language request. And then for the vectorizer, I will use an Azure Function because I told you that all the session description and title in my database must be converted in an embedding. But I'm not inserting manually all the vectors every time I add a new abstract or title, right? So there must be something that as soon as I add the title and the abstract, it calls to OpenAI, get the embeddings, stores them back in Azure SQL. And that something is an Azure function using something we just GA'd called a SQL trigger binding, which means you can ask an Azure function to monitor a table for changes. Every time there will be a new row or an updated row or a deleted row in the table you are monitoring, the function will be executed for you. It's very easy to react to what is happening in a database, like someone inserting a new session from the administrative backend, and just fire off an execution so that we can call OpenAI, get embeddings, and store them back in SQL. And you will see that. Database is Azure SQL. we have a free tier right now, completely free, like not after 12 months we have to pay. It's completely free. And it's more, of course, it's limited to, I don't remember now how many cores, I think 2 and to a number of 100,000 seconds per month, vCore seconds per month, if I remember correctly. But it's free and it's perfectly fine for this example. Otherwise, of course, if you already have Azure SQL, you can just use any that you want. Is this solution scalable? Because many then ask, okay, but I'm a big company, will this scale to 100 or 1,000 and 10,000 of people? Yes, because everything is serverless and stateless. So static web apps are serverless and stateless by definition. Data API Builder is this application that helps you to expose your database as a REST and GraphQL endpoint and is stateless by definition. So if you have so many requests coming in as a HTTP request to run your storage procedure, you can spin up 10 of these Data API Builder instances and they will just work connected to the same database. For example, using containers, Kubernetes, or whatever you want to use to run Data API Builder. In my case, since I want to have the easiest option here, I don't even have to spin up Data API Builder because Data API Builder and static web apps are tightly integrated together. So whenever I deploy a static web app, I can also ask to have an instance of Data API Builder running already for me. So I don't even have to deploy it. I just have to configure it. Say, hey, this is my database. This is the table I want to expose. That's it. I don't even have to worry about deploying Data API Builder along with static web apps. Azure Functions, again, they are serverless. I created a function that is fully stateless, so it will scale as much as you want. Azure SQL, of course, the free tier will scale up to a certain amount, but then if you need more, you can just go hyperscale, and hyperscale allows you to have up to 100 terabytes, 80 vCore, so it's really ultra scalable, and basically it just gives you the peace of mind that you don't have to worry about moving to other architectures or change database because it just scale as you need. That's it. So the architecture is also flexible because it's all a full stack Jumpstart architecture. So for example, the very first version of this example, I think I wrote it in Vue, but then Aaron Powell, a friend of mine, helped me to rewrite it using React to be more nice. And of course, just the front end was needed to be changed because the backend and the API didn't change. So we were able to just make a nicer front end without touching the backend. We use a microservice architecture, so it's very scalable. We use an event-driven architecture to make sure that as soon as someone changes data in database, we fire off the execution of storage procedure to get the embeddings. And in general, it's very easy to update and expand because all layers nicely interact with the other, but everything is very loosely coupled. Now, one question that people ask me here is, okay, I heard about vector search, but I know that, or I understand that you need to use a specialized vector database to do vector search because vectors are not something that a relational database can manage. That's actually not true because vectors are number, actually sequence of numbers. And a vector and a database like Azure SQL and SQL Server are perfectly suitable to manage list of numbers, which are tables or just arrays. And in the V1, I did some measurement. We used the first version on the .NET conference 2003. We had several thousand people online. It was an online conference, all searching for like, give me this session or that session. And the average vector search was 29 milliseconds, so pretty fast. Anyway, and yeah, it was just scaling as much as we needed. So you both have still version 1 and version 2 if you want, but of course we'll be focusing on version 2. And version 2 is especially the front end has been rewritten in React with TypeScript. Everything has been rewritten to use .NET 8 using OpenAI SDK. And just as a proof how this microservices architecture worked so well, in just a few days of work, which 90% was on UX, we were able to move from V1 to V2, which required kind of, for example, the natural language processing part, a better UI. And so it's just very easy to adopt. So you can imagine that you can go to this website, deploy, or even just clone it on your machine, run it if you're happy. The first thing I would do is try to change and configure the things so they can work on your own data, and then try to change maybe the UX, and then just start from there and play with it, see what it brings you. Okay, so one important thing here that I'm going to show you. What I'm going to show you, this repository has two branches. One is called main, which is the one I'm going to use, and it uses the new vector support we are working on right now. My engineers are working on that right now, so that you can just store a vector as a vector and manipulate it as an atomic unit. Now, this means that it's only available in Azure SQL, and actually it's in preview right now, so you have to go to this website, to this link, and submit your request to enter the private preview, so that you can use Azure SQL with the vector support. This will just make your life much simpler, and the code much simpler, but handling vector is also possible without having a vector type, because again, vector can be stored in the tables. So the branch called classic in this repository will actually show you how you can do exactly the same example, deploy it, run it locally, just using plain old SQL Server. So if you are on the SQL Server and you can't use Azure for any reason, and you still want to do vector search on your own data in your own SQL Server, you can. It's slightly more complex, but not much. So what I'm showing you right now will be the evolution of the vector support that we are working. It's nice to see what we are working on. I think it will also give you a glimpse of where we're going. But again, keep in mind that whatever you want to do is still doable perfectly in SQL Server. Okay, let me go to the VS Code here. I already cloned the repository. And the repository, first of all, everyone in the back can see clearly, or I need to zoom in a bit more? Okay, go. Okay, yeah, seems perfect. Okay, so this is the repository you will be cloning. And actually, let me go here. How do you go to the repository? It's very easy. Just go to AI, microsofthq.vslive.com, click on the GitHub icon here, and then you will be sent to the repository. Okay. Then you clone it as usual, and that's it. And here you see you have main and classic. So I will be using main, and here below in the README, you have all the explanation how to get into. So what is the difference between native, so the main one, or classic, how to ask to get into the private preview, an example of what you will be getting. If you switch to classic here, you will have, of course, the README that explains to you how the classic thing works, and you will have, like, for example, a link that explains to you how to store vector in SQL Server without having a vector type. So you can, understand how things works behind the scene. Let's go to the main one, or the native one. And so I cloned it, and everything is here. So the important part is that we have the database here. And the database is super simple. Let me go to show you the tables. We have a session table that contains information about the session, title, abstract, and of course, at some point, we have the embedding. Embedding, when you use the private preview for vector support, today, oops, maybe it's better if I close this. Come on, okay. Are stored in a var binary. So you will be storing your vector. There are specific functions that you can use to generate a vector and store them in a var binary. So embeddings are stored in a var binary. Then, for now, we are working on making this vector. But since we had so much requests from customer that they wanted to test out vector as early as possible, we started saying, okay, let's start with the var binary. Then we'll provide you the vector type and, of course, a nice migration path. At the end of the day, all is binary behind the scene. So up until today, if you go and ask to enter the private preview, you will be able to store your vector in var binaries. And here I have my session table. Then I have the speakers table again. I have the full name of the speaker. I will be turning the full name into embeddings also. So you can, for example, find me, even if you misspell my name in the speakers, right? And then, of course, the relationship table between session and speaker, because this is a many-to-many relationship. Nothing else. Then we have a couple of interesting things. The find session. So find session is a storage procedure I want to use to say, okay, you provide some text, and I want to take that text, convert into an embedding right from SQL, and then calculate the distance between the resulting embedding of the text you typed and all the session I have in my database. So I have a stored procedure here called get embedding. Let me show you what it does behind the scene. And the key of get embeddings is sp invoke external REST endpoint. This stored procedure calls any REST endpoint that are available in Azure. And luckily for us, almost everything is a REST endpoint today. So for example, you can call OpenAI model rightly from Azure SQL, pass the text that you want to convert into an embedding, and right from SQL, you will send the data to OpenAI. OpenAI will do its magic, return to you a JSON containing a vector in form of a JSON array, and then you will be using JSON array to vector, a new function that we will enable for you if you enter the private preview, that is able to take a JSON array and save it in our binary vector form. So this get embedding, what is actually doing is taking, so let me do from here, let's do get embeddings and pizza. And what I need to do is specify an output. So let's do, declare, let's say E var binary 8000. This will be the variable containing my embedding. And here I would say E output. Output, E out, I can do it, thank you. And then we can do select E. And then let's see what happens. Now, this is calling to OpenAI. So it's making a REST call to OpenAI, to a model I deployed, and it's converting the term pizza into an embedding. Of course, here you see only the binary representation, which doesn't mean a lot for us. So what I can do is do vector to JSON array, which is another function we created in order to allow you to see the vector. And basically, if I run it again, there's a little bug here. Okay, you will see the vector. So this is the representation of pizza in the AI mind. Now we can take this vector, compare it with all the embeddings I already stored in my table, and see if there is any session on pizza, or probably better, security. And actually, let's take, see if I still have it around. No. Before I wrote something like, I want to learn about security. And basically, this will still be a vector, right? So I can take this vector, and then this is exactly what my stored procedure will be doing. Take the vector here, and then, so find session here. So get the embedding or the vector of a given text, store it in a QV query vector variable, and then calculate the distance between my vector and all the embeddings, in this case of the speaker or all the session. Now, the first question here that comes up is, okay, that's great, but in my session table, I only have titles and abstract. How do I convert them to vector? I have to manually call these get embeddings for every row? Well, yes and no. We can, well, of course, that would be an option, but not very smart. What we can do is use Azure function and Azure function trigger binding. So let's go back to, now that you have seen the database, which is very simple, let's go to the function part here that contains the logic in my backend. And then let's go to session processor. Session processor, it's a C# application or library that uses this nice attribute, SQL trigger, which says, please monitor the web session table using the connection string that is available at this environment variable. And every time there are changes, fire this method. So the method will contain a list, an I-read-only list of changes. So we know if a row has been inserted, deleted, or updated, and we have access to the entire row. So here I created a class that represents, for example, my session, a title and an abstract, because that's all I need, because I want to turn my title and abstract, I concatenate the title and abstract, and I want to turn it into an embedding. So that's the only thing I need. I don't need the other columns, right? The item is just a kind of a common element, because all my tables will have an ID, and all my tables that will be monitored by Azure function a specific column that tells me if I need to calculate the embedding or not. Let's say, for example, you updated the hour at which a session will be delivered. You don't want to update the embedding there because title and abstract hasn't changed, right? You just updated the hour. So there is no point in calling OpenAI to calculate an embedding that will be no different than the one you have. You will be just spending money for nothing. So here as a technique, I added, let's see, I added a column web.sessions where if, and in this case, the table is empty, of course, but if my required embeddings update is set to 1, I know that I need to recalculate the embedding for that row. So I only do it when it's actually needed. So let's try to do it. Let me run this function. So let's go to the function and do function start. Right now, I'm just manually running the function. It will not be needed, but I just want to focus on this part right now. So function start, and then we will be adding some data. So we'll be adding a speaker, and we will be adding a session, right, an abstract, and then we'll be associating the speaker with that session. Now, please note that in my session that I'm adding, I'm not adding the embeddings, right? I'm just adding the title and the abstract, but no vector here, no embedding. So yes, this is running. So I have two SQL trigger, one monitoring the session table and the other monitoring the trigger table. So if I execute this, I would expect here to see something happening. Exactly. So the web speakers 5000 has been detected as a change. So it's trying to get the embeddings. And then, perfect. Same will happen on the session. Done. So basically, the Azure function monitored the table, detected the changes, and now if I go and take a look at the session here, you will see that now I have my embedding. Perfect. So now I can keep going on, adding session, adding titles, and that's all I need to do. Let's also add another session here, again, the one on pizza at this time. So let me add this one. What will happen is that you will see again this firing off. Yeah, there is a new session. It needs to have the embedding process, so it's doing it fantastic. And now that embedding are available in my table, I can, for example, go to, actually, I think I already have it somewhere, maybe here. Nope. Okay, so let's do execute web.find session, and I want to learn about security, for example. Yeah, let's, oh, actually, about AI on my data. Let's see what kind of session will return as well. There is only one. Yes, it's returning the session on OpenAI. Well, actually, no. I think I added the other session too, the one on pizza. So here is in my find session, there is by default a filter. Yeah. So this is filtering. I established that with this model, with this kind of data that I'm using, everything that is lower, everything that is less similar than 0.35, I want to filter it out, right? So that's why you only see of the two sessions I have, because if I go back to my table, let's close this one, is empty. I think the session here, yeah, I have two sessions, but of course I only got the correct one because here I was able to find that threshold that works for now. And here, if I want to learn about pizza, no, let's say not pizza, about something that is related to pizza, about to cook a good meal. Okay, so there is nothing in pizza here, but of course pizza is more similar to a meal than something else. Oh, in this case, it's still not working. And you see, that's why you probably want to be very careful on the threshold you set, because it's tricky to find the right data, and that's why here. That's why you probably want to do the RAG pattern in order to make sure that it will be the AI to figure out what is the right session to answer the data. But in this case, yeah, 0.32, that's why the original threshold was 0.35. In this case, the most similar thing that I have related to how to cook a good meal is, of course, learning how to do pizza, not the security or the SQL AI session. So fantastic. What we've been able to do is use Azure SQL to call OpenAI using a REST endpoint, get the embedding back into database, and do vector search using the new features. But again, the same would have been with the regular SQL Server. Of course, there you will not have the vector distance function natively. You have to write on your own, but it's like 10 lines of code is not much, but you still be able to do the same. And in the repository is explained, if you go in the classic one, how to do that. Now, we are halfway through, because now we know how to store data, how to get embeddings, how to filter and do similarity search. Now we need to set up also the UI and the machine learning part. Sorry, the natural language part. Now, first of all, the thing I want to do, because I want you to be able to have an experience, is, not this one, this was the old one. AI.Microsoft, this one. So I want you to be able to just experience vector search, so you can get confident, understand exactly how it works, and maybe it's enough for you. In your case, you don't need to do RAG. I want to expose my storage procedure here and make it available as a REST endpoint, right? So the only thing I need to do, thanks to the fact that I have a data API builder embedded in static web apps, is create this configuration file, and let me show it to you, and basically say, I want to expose my web.find session, which is a storage procedure, as an endpoint called find related session. These are the parameters I'm expecting to have. Text must be, it's mandatory. If top and mean salary will not be supplied, I will be giving this default. I don't want to expose it as a GraphQL. I want to expose it as a REST endpoint, and the path at which this storage procedure will be available is /find, and it will only accept a post method. So let's run it. So let's do SWA. So again, here I have two options here. I can just run Data API Builder on its own, but then I have to figure out how to connect it with the front end. And here I have Data API Builder installed already. To install Data API Builder is very easy. .NET tool install, and then you do Microsoft.Data API Builder. If you want to, for some reason, you say, I don't care about the front end. I just want to run Data API Builder. Just expose my database as a REST and GraphQL endpoint. But in our case, we are building a front end, a full stack application, so we need also the backend to be able to communicate with the front end. So we are using static web apps, and static web apps will make it easier for us to make sure that the backend and the front end can communicate, and no CORS issues, no security issues, everything is taken care of for us. So what I can do is just do SWA start. And SWA start, SWA is the CLI for static web apps, has been already configured here. And I'm saying, look, in this static web app application, there is the need for Data API Builder, so please spin it up for me, and read the configuration from this folder. Okay, so when I will be doing SWA start, what will happen is that the function will be executed behind the scene for me as a regular static web apps app. So the function can monitor my table, can monitor my HTTP request that I will describe later, but also it will be started also. So this is the function, and then I also want the Data API Builder to be started. So let's do it. SWA start. You will see that in a second, Data API Builder is starting. And then, of course, also functions will be starting. And drum rolls. Okay, well, at some point it should start. And then we will have both the Data API Builder available and the function, and the website will be running locally. If Visual Studio Code agrees with me, let's see. Otherwise, I will just stop this and let's just kill this, and just maybe let's do it from, I should just work from here. So let's try again. I'm in the right place. Yes, SWA start. That's the only thing. Let's see if now it's happier. Yes, thank you. So first of all, you see that Microsoft Data API Builder is executed for me behind the scene automatically because it detected that we want to use it. Then it's also starting to run the Azure function. Perfect. And so in a few seconds, we will have the Azure function monitoring the table for making sure that whenever we add a title and abstract, we get embeddings, and also the Data API Builder, so that we can have the storage procedure. Or in the meantime, this starts, let me show you also what else I want to expose. For example, here I want to expose another storage procedure that tells me how many sessions I have. And in general, just an exercise here, I want to expose the entire table web session so that at /session, you will be able to see the content of my table. You will only be able to read it. I don't want to do any post or any delete verb on my table, so you will only be able to read it, and that's it. So this should be, it's probably running, yes. So let me open this, and this is our local website. So if I click on about, there are 2 sessions. So what happened here? Well, my storage procedure, another storage procedure that counts how many sessions there are in my database, has been called via REST in this case. So let's take a look at where this thing happened. Actually, let's first of all do this one. Let's go to search. Let's say I want to learn about SQL and actually AI on my own data. Nice, that's exactly the session we want to go. So what happened behind the scene and why this is working, and how come the storage procedure behind the scene has been executed for us. So if I go here, you will see execute web find session. This is the API builder in action. So it was listening on a HTTP port, and more specifically here, let me just show you HTTP localhost. I need to go to the behind the scene one. And let's go here, Swagger. That's it. That's my database. The storage procedure, the other storage procedure, and my table. Now, the table here you see, at the moment we show all the session and the methods because we don't know what kind of authentication level you have here. So we just give you all the methods. In this case, if we try to do a put, I will get a 401 because I'm not authorized. I'm only authorized to read, right? So, but here in this case, for now, we just list all the possible things that you can do because we don't know what kind of authentication token you are presenting. I haven't given any here. But this is how simple it is to actually expose my database as a REST endpoint. And as a proof of that, if I go to find, sorry, if I want to see where find is used, I can go to my client application, so my React application. I go to the source of my application, the API, go to session, and this is exactly how we get the session. We we basically make a post request to data API /REST/find. So data API /REST is there because we are using data API builder through static web apps. So static web apps knows that when we call data-API, we are routed to the data API builder, and data API builder is configured to listen on the REST subpath, and on the find subpath, specifically, it will call the storage procedure mapped to that subpath. If you go here in the configuration, you will see also the REST part. So here we are saying the storage procedure web find session is mapped to the path find, but in general, at the runtime level, data API builder will be listening on the /REST subpath. So that allows you to customize and how to route the request to the API builder so it doesn't clash with other routes that maybe you already have for other reasons, right? So this is all the API builder, and it's just working. Just for those who want to use GraphQL, we also support GraphQL. So here I have enabled GraphQL support for sessions only. So let me cancel this. So this is something you get for free when you use the API builder, because we have partnered with Hot Chocolate, and Hot Chocolate, it's the GraphQL engine, also comes with a nice playground, and this is enabled only because I configured the API builder here to work in development mode, where you have access also to things that you should not have access in production, right? You have plenty of configuration options in the API builder, but in the runtime section, you decide how the API builder behaves. And here you see that I'm in development mode, which means I have more log. I have access to things that normally you would not allow people to access in production, like, for example, the GraphQL playground. But here I can say, okay, let's do a query. And I want to find all the sessions there. And for all the session, I want to get the ID, the title, and that's it. Run. That's it. That's my database. That's my table, right? So Data API Builder really allows you, in a snap of a finger, to take your table, view, and storage procedure and turn it into an endpoint. We support authentication, authorization, caching. You can decide if to use GraphQL or REST or both. So it's very, we support, of course, pagination, filtering, sorting, of course. So everything that you would have written yourself to expose and to create a simple, in quote, CRUD service, which is never as simple as you imagine, because even just paging or security is complex, is basically provided for you for free by Data API Builder. And it's open source. So you can just go and take a look at how we are doing things if you like it, and just adopt it for free. It will work on premises, it will work in the cloud, even in other cloud if you want. So it's just a free tool that we created because I was completely tired of creating the CRUD service for the billionth time again in my life, and it's always the same, right? So finally, I can focus on doing vector search. That is much more interesting because the only thing I had to do is do my storage procedure, expose it, and then I can do other interesting stuff like the natural language things and whatnot. Now my application here is running, so everything is good. Let's go back to the application. Now, how do we do this last part, like the natural language thing? So here I want to say, hey, there is anything for me if I want to learn SQL. And what is happening right now? The endpoint that now is being called is not the storage procedure, because that is too plain if you want. That is only doing vector search. We said that we need to do vector search and then call a more sophisticated model like a GPT model, right? Perfect. So what we need to do is go to the function and not look at session processor this time, but a chat handler. Now, chat handler is interesting because it shows you exactly the prompt engineering at work. So this session handler is nothing more than a listener to a post, to a HTTP port, post method. And basically, every time you type something in here, okay, you will be, basically, this payload will be sent to this endpoint, ASKC. And in fact, this is basically our chat, what we typed in the search box. So what we are doing here is, first of all, executing, in this case, without going through Data API Builder, because there is no point here, I can just execute a storage procedure, searching all the sessions that are somehow similar to this text. Then I'm getting a list of sessions, and I am doing something interesting here. I am taking all the session, the ID, the title, the abstract, the start and the end time, and concatenating it using this kind of format. Title, pipe, abstract, pipe, speakers, and so on and so forth. Then I'm doing something interesting. I am telling to my AI model, which in this case is ChatGPT 3.5, that you are a system assistant who helps user to find the right session to watch from the conference, based off the session that are provided to you. So first of all, I'm explaining the AI model that I'm providing some session. How am I providing that session? Session will be provided in an assistant message in the format title, pipe, abstract, pipe, speaker, and so on. So that's why I am formatting the session by concatenating them in that specific way, because I'm telling you, AI model, that you will be receiving the session list with this format. So I need to, be compliant with what I specify and explain to the AI model. And then you can use this information to help you to answer the user question. So somewhere I need to specify also the user question. So let's go a little bit below here. It is just on top because this is a constant message. This is what is called like the system message, which basically helps you to kind of initialize your AI model, explaining who are you in this specific context. You are an AI assistant for conferences, right? And then here, once you have the message put together and all the session concatenated, you basically send this specific message to AI model, and you say, between source and end, you specify the session description, so the concatenation of all the title and the abstract and everything, right? So this is basically the result of your vector search, transformed into a string separated by pipes. So this is basically the payload, the context that the AI model will have. And then you explain that you need to answer by providing two sections. The first section will add, will be the answer to the question. The second, I asked specifically, and sometimes you need to be very precise, create a, because you will get back some text, right? In this case, the new model allows you also to get JSON, but when I created this one, you couldn't. So here I needed to be very sure that between the answer and the explanation of the answer, the AI model would have put exactly this text. So in the second section, that must be named exactly dash 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 thoughts dash dash dash. And you must use exactly the same, the name as typed without any changes, because sometimes it was returning like capital case, like, man, why? Or with less spaces or whatever. Anyway, so you need to be very, very, very precise. And then basically you provide this this message to your AI model. You provide the context, you provide the system message that tells him how to behave, and then you will get an answer in a text format, right? You have basically a text answer, just like if someone is answering to you just by writing. And then you have to, again, now you can just ask a JSON answer, but not when I built this. And so here you basically now take the answer. So you get you do get chat competition async, which is allow you to get the answer. Behind the scene are all REST requests. So this SDK that I'm using, the Azure OpenAI SDK, is basically encapsulating the REST code that you would have to make manually. So it's just nicer because you just interact with classes and methods. And basically you get the result. And then once you get the result, in these cases, I ask the result to be split into the answer and the toss that brought to that answer. I need to do some manipulation of the text. And then basically I just return the answer with the toss to my front end. So let's take a look here what happened. So let me do F12. This should be Zoom 2. Let me ask again. And if you go to network, where is it here? Let's ask it again. Let me zoom out a bit, a second. Okay, here we go. Ask. And then I'll zoom in later, but I want to show. So this is the payload we sent. Hey, so this is the text, my question. We enrich it with the system message, with the context of the session returned by the vector search, plus this message. The response is this thing here. Come on. Okay. The response is, okay, let me zoom out. This one here, and okay. Yeah, so basically this is the answer I get after I processed it and split in answer and thoughts. And everything is happening, again, on my machine in this case, so everything is completely running locally except with Azure SQL, because that's where we have at the moment the vector support. But you can easily imagine now to basically just take this example, deploy it again on your machine if you want, and then instead of using my session speaker, you can have products, for example. Help me find the best product to do a birthday party. And then you feed it, your table is not the session table, is your product table. Or you have a document about security in your workplace. Is these things I'm doing okay? And you can get the answer, right? Is this contract still valid or whatever? You can build this kind of solution starting from this simple application. Questions so far? We have just 10 minutes, which is perfect right now for any question or anything. Is all clear? Yeah, one question there.
How would you approach adding the session date times to your embedding?
How do I approach session date time to my embedding? So AI models are not super good with numbers, right? We are trying to find how to make them good, and I think we may have a solution, but at the moment what you really want to do, and that's why it's very important for me to use vector search in SQL, is that you want to maybe do some hybrid search. Like, yeah, I want to search for vectors, yes, but then I have my table where the column start time is, structured. So I can just do where distance equal or less than a certain threshold, and then the usual predicates, like where the date between or this kind of stuff. Because for this very precise number, AI models are at the moment very bad. right? So you need to come up with what I call, and the market hasn't come yet with a definitive kind of name, hybrid search, where you mix relational search with vectors or semantic search, maybe full text search, and just mesh everything together so you can have the best search result, depending on what kind of question has been kind of defined. Any other question? Oh, one there. Oh, yeah. So the question is where we decided on which field we should create embedding on, and it's here. So, well, first of all, it's something you have to decide, right? So when I created my table, and again, the design could be different in some case, but here I decided to store the embeddings right in my session table, here. In your case, if you have a table that you cannot touch, what you can do is create another table, have a one-to-one or one-to-many relationship, because there are some cases, let's say you have a table that contains books, like literally the text of the book. Maybe it's like, I don't know, 10,000 words. You cannot generate, well, you can create an embedding out of the 10,000 words, but probably you don't want to, because one embedding represents usually one topic. And in your books, probably there are several concepts that you want to represent. So you need to do something that is called chunking. Basically, take text of your book, let's say chapters, and create one embedding for chapter, right? In order to help to preserve the meaning, the AI model to preserve the meaning of each chapter. Otherwise, it would be like, can you summarize a book in one word? It's very hard, right? If I ask you, can you summarize a chapter with one word? Maybe it's a little bit easier. If I ask you, can you summarize a sentence in one word? Okay, you have more data that is that can help you to identify maybe what is the chapter that is related to some topic you are searching or another one. So you probably want to, depending on how much text you need to convert into an embedding, have the embeddings in the same table or have a dedicated table that only contains embedding. And then it's up to you to decide if it makes sense to add the tags to the embedding or the external ID or just the title and the abstract. Usually you want to capture embedding or something that is text, image, or audio, because those are the things that contains information for us, right? Creating an embedding on start time for the same discussion we had before, everything that is numeric today is not very well managed by AI models. So I would not create an embedding here, for example, but definitely I would create an embedding on title and abstract. And actually what I did here, I added together title and abstract and created embedding on the concatenation, right? And where this happens is here in the function. So if I go in the function that is running behind the scene here, you have this session processor, and here you have this attribute that says SQL trigger. So every time something changes in the session table, this code will be executed. Here I take the title and the abstract, I concatenate them, I put it in a property called payload, and then I call this method process changes that is not doing anything else than just calling the OpenAI client and then getting the embedding. So this is exactly where my text is converted into embedding. Okay, so it's in the session processor file here. It's one way to do that. Again, at the end, this behind the scene is an HTTP call. So you can use the SDK, you can do the HTTP call as I did in Azure SQL directly. This is, so this code here is absolutely equivalent to this one. Where is get embeddings? Let me find for you. Yeah, basically, this is what is happening behind the scenes. So the code in my Azure function is calling my deployment, openai.azure.com, my embedding model, and passing a payload. And the payload is nothing more than a JavaScript, than a JSON object where you have one property called input and then the text that you want to convert into embedding. Okay. Other questions? Otherwise, we can go. Yeah, one here. Yeah. So the question is, the TP Builder works with hot chocolate. Will work with Postman too? Yes. But any REST client will work with data API Builder because it's just exposing a REST endpoint. So you can use Postman, you can use Insomnia. Now there is a REST client also in VS Code. So as long, even curl, so as long as you can make an HTTP call, it will work. Yeah. Say it again, sorry, the response? Oh, okay. So the question is, if the API Builder is giving me an answer in via GraphQL, and I have another API that also returns me GraphQL, can I merge them together? No. The API Builder doesn't do that, but we don't need it to do, because there is a very cool product from the hot chocolate company, and actually guy, Michael Stipe, that is called Fusion, that does exactly what you want to do on premises. If you want to do it in Azure, you don't even have to do that because there is something called API management that will do that for you. So all these service like API management in Azure or Fusion on premises allows you to take GraphQL that is coming from different sources and stitch it together. But that is something we decided not to do because there are already tools that does that. So doing it in Data API Builder would have been like not needed because you can just use the right tool for the job. Okay. Data API Builder, since there's a couple of questions here, you can find it aka/ms/DAB, and that's Data API Builder for you. So it's everything is completely developed in open source. So there is an explanation here. It's fully documented. So it's something we own as a team. So it's fully documented. Documentation is amazing. There are a lot of samples. It supports multiple database, actually all databases that runs in Azure. So it supports Postgres, MySQL, Cosmos, and of course Azure SQL. And it basically helps you to just avoid to, again, reinvent the wheel every single time. So check it out because I think it's worth your time. So let's go back to the slide. So I think we covered everything. Again, make sure some resources for you or for your colleagues if they are interested in getting into Azure SQL and developing with Azure SQL. Remember to tell us what you want. So please, please, please fill out the survey. Data API Builder, Azure, everything that you saw today is because we ran this survey 3 years ago. And we got very clear feedback that users wanted to have ability to call a HTTP REST endpoint from Azure SQL. They wanted to be able to select a storage procedure and make it a GraphQL endpoint. So please, I think we did a lot. Now it's the time to ask you what you need more. So please fill this out, aka.ms/data-dev-list. So it's basically your wish list as a developer with Azure SQL. And it's our kind of mission to make sure that we can deliver as much as you ask us to you to make you as much productive as possible. Make sure that you also fill out the survey about this session. And I think we can take another questions if you have any. Or, yeah, one there. Yeah, good question. So summarize the question is how having embeddings in my database will make it bigger, right? Embeddings are very big. Usually you have, so for OpenAI embeddings, today the most common dimension is 1536 dimension for each vector. We store each dimension with a single precision float, so it's 4 bytes. So this means that one data page, like 5K, goes just for storing one vector, right? So it can be very big. Like if you have 1 million of vector, I had a test with, I think, 8 million of vector. The database was like 100 gigabytes, just for vector, right? But that's it, like it's what we have. Now it seems there are models that can give you the same quality with less dimension. We are looking at how to quantize vectors in order to kind of compress them without losing quality. But yeah, it will make your database significantly bigger. Yeah. Sorry, can you repeat? I haven't heard it. Yeah. Yeah. So the question is, can we index vectors, basically? So we are working on it. Soon you will see something. At the moment, if you start the private preview, you will not have a vector search index support. Having said that, with all the customers I spoke with, it's never a question on searching only on vectors. It's usually, imagine we did a test on the Yelp dataset. It's like 10 million reviews, right? You never want to search to find like a restaurant in all the reviews you have. You want to search it by geography, by category. So you really want to have the hybrid search. We noticed that in that case, it's already very fast. We understand that there are cases in which you need to search among like 1 million vector. So we are working on adding ANN, so approximate neighbor, nearest neighbors index on Azure SQL and SQL Server, but it's not there yet. It will come soon. Oh, which this one or this one? Cool. Oh, the book. Sorry, sorry, I didn't hear. Yeah. And cool. That's it. So hopefully you liked the session. You learned something. Thanks a lot.